Welcome to Tech with Kaushik. This is part 15 of our complete practice question series for the AIF-C01 AWS Certified AI Practitioner exam. Choose your answer before the timer ends, then review the correct answer, explanation, and exam tip. Let us begin part 15. Question number 390. This one tests your understanding of bias and fairness. Scenario. A global streaming service is preparing a dataset to train a content recommendation engine. The preliminary dataset predominantly contains viewing habits from users in a single geographic region. The company wants the model to perform equitably for users worldwide. Which data preparation strategy will best support this goal? Options. Option A. Remove records from underrepresented regions to make the dataset more uniform. Option B. Curate representative training data across geographic regions and relevant demographic groups to reflect the global user base. Option C. Restrict training to the dominant regional dataset because it contains the most records. Option D. Oversample only the already dominant region to increase statistical confidence. The best answer is B. Curate representative training data across geographic regions and relevant demographic groups to reflect the global user base. Representative training data exposes the model to the usage patterns of the populations it will serve. Including adequate examples across regions and relevant groups helps reduce representation bias and supports more equitable evaluation and performance. Check why each remaining option is not the best fit. A. Removing underrepresented records increases the imbalance. C. Training only on the dominant region limits generalization to other populations. D. Oversampling the dominant region further amplifies the existing skew instead of improving representation. Remember this decision rule. Diverse and representative data can reduce representation bias, but fairness should still be evaluated across relevant groups after training and deployment. Let's break down question number 391. Review the scenario and identify what must be achieved. An enterprise data science division is standardizing its tooling. It needs a centralized environment where data engineers, analysts, data scientists, ML developers, and generative AI builders can collaborate, share GAN resources, and develop data, ML, and generative AI applications without switching between fragmented platforms. Which AWS service or capability provides this unified development experience? Now compare the choices one requirement at a time. Choice A. Amazon Bedrock Prompt Management. Choice B. Amazon Q Developer. Choice C. Amazon LEX. Choice D. Amazon SageMaker Unified Studio. The correct choice is D. Amazon SageMaker Unified Studio. The decisive reason is Amazon SageMaker Unified Studio provides a collaborative environment for data engineering, analytics, machine learning, and generative AI development. Teams can work in shared projects with access to data, compute, tools, and GAN assets. The incorrect choices are plausible, but unsuitable because A. Prompt management stores and versions prompts but is not a full data and AI workspace. B. Amazon Q Developer is a developer assistant, not a shared end-to-end data and ML platform. C. Amazon LEX builds conversational interfaces and does not provide integrated data, analytics, and ML development. Watch for this clue in similar questions. Choose SageMaker Unified Studio when multiple data and AI roles need one governed, collaborative development environment. Approach question number 392. By checking every constraint. This question moves us into Bedrock guardrails. Look for the wording that eliminates the distractors. A media company is rolling out an AI assistant powered by Amazon Bedrock to help users discover entertainment content. During testing, the assistant occasionally provides opinions on current political elections. The company strictly forbids the assistant from engaging in political discourse. How can the company enforce this restriction natively within Amazon Bedrock? Watch for distractors that are valid services but wrong for this scenario. Next, option A, enable Amazon Bedrock guardrails with a denied topics policy. Next, option B, deploy Amazon SageMaker model monitor to filter inference requests. Next, option C, configure an Amazon Bedrock agent to block unrecognized intents. Next, option D, use Amazon SageMaker Clarify to measure political bias in the prompts. The required response is A, enable Amazon Bedrock guardrails with a denied topics policy. This option satisfies the complete requirement because Amazon Bedrock guardrails allows organizations to implement safeguards tailored to their use cases, including blocking specific denied topics, such as politics or religion, across foundation models. Here is how to rule out the alternatives. B. SageMaker Model Monitor monitors deployed ML models for data drift, not native topic blocking for Bedrock. C. Agents orchestrate tasks. They are not the primary mechanism for enforcing topic-level safety guardrails. D. SageMaker Clarify detects bias and explains predictions. It does not actively block topics in generative AI. Exam strategy. Use Amazon Bedrock guardrails to enforce responsible AI policies like filtering harmful content or denying specific conversation topics. Now tackle question number 393. Scenario. A healthcare organization wants to use its internal policy documents to provide grounded answers via a large language model, LLM. They are designing a retrieval augmented generation, RAG, architecture. Which step is required to prepare the text documents so that a semantic search engine can retrieve the most relevant passages for the LLM? Compare the options. Choice A. Apply one-hot encoding to the vocabulary of the documents. Choice B. Break the documents into chunks and generate vector embeddings. Choice C. Encrypt each document segment using AWS Key Management Service, AWS KMS. Choice D. Tag the entire document repository with comprehensive metadata labels. After elimination, select B. Break the documents into chunks and generate vector embeddings. The key clue points here because in a RAG workflow, large documents must be split into smaller segments, chunks, and converted into numerical representations, embeddings, so a vector database can quickly search for semantic similarities when a user asks a question. A. One-hot encoding is a technique for categorical variables in traditional ML, not semantic text search. C. While encryption is good for security, it is not the mechanism that enables semantic retrieval for RAG. Tagging metadata is helpful but does not provide the semantic vector search capability required for RAG text retrieval. Use this elimination rule in the exam. The foundational data preparation step for RAG involves chunking text and creating vector embeddings. For question number 394. Separate the requirement from the distractors. The focus now shifts to generative by. Identify the decisive constraint before considering the options. A retail company's management team struggles to extract actionable insights from large dashboards. The team wants a solution that can generate written executive summaries, explain data trends, and create data stories from existing business intelligence dashboards. Which AWS service provides these generative by capabilities? Eliminate every option that violates even one requirement. Consider option A, Amazon Textract. Consider option B, Amazon Polly. Consider option C, Amazon QuickSight. Consider option D, Amazon Recognition. The option that satisfies the complete requirement is C, Amazon QuickSight. Here is the reasoning that confirms the answer. Amazon QuickSight provides generative BI capabilities within Amazon Quick. Users can ask questions about data, generate executive summaries, build visuals with natural language, and create data stories from dashboards. The remaining options fail one or more requirements because A. Amazon TextRact extracts text and structured data from documents. B. Amazon Poly converts text to speech. D. Amazon Recognition analyzes images and video. For AI-assisted dashboards, executive summaries, natural language analysis, and data stories, choose Amazon QuickSight. Question number 395 contains an important exam distinction. The key exam clue is contained in this scenario. A financial institution upgrades its loan approval logic from a standard decision tree to a deep neural network. The new model identifies risky loans more accurately but makes it much harder for loan officers to explain to applicants exactly why they were denied. Which fundamental machine learning trade-off does this scenario illustrate? The exam distinction is hidden in these choices. Now, examine choice A, sacrificing model portability to achieve better regulatory compliance. Now, examine choice B, improving predictive performance at the expense of interpretability. Now, examine choice C, enhancing explainability at the cost of higher inference latency. Now, examine choice D, reducing bias in exchange for a lower overall accuracy score. The required response is B, improving predictive performance at the expense of interpretability. The requirement to solution matches deep neural networks typically offer higher accuracy, performance, on complex tasks than simpler models like decision trees, but their internal workings are a black box, making them much harder to interpret and explain to stakeholders. Now, eliminate the distractors. A. Portability is not the primary trade-off when moving from trees to neural networks. C. Inference latency may increase, but the core AI transparency trade-off is performance versus explainability. D. Neural networks do not automatically reduce bias, they can easily amplify it if the data is biased. A useful exam pattern is this. More complex models, like deep learning, often increase accuracy but decrease explainability compared to simpler models. Focus on the key wording in question number 396. Focus on the requirement that drives the design choice. An advertising agency uses Amazon Bedrock to draft copy for various client campaigns. The prompt engineering team has developed a highly effective set of instructions. They want to save this template and dynamically insert different product names and descriptions at runtime without rewriting the base instructions. Which Amazon Bedrock capability is designed for this workflow? Focus on which option satisfies the complete requirement. Option A, prompt management. Option B, cross-region inference. Option C, knowledge bases. Option D, model evaluation. The best answer is A, prompt management. Amazon Bedrock prompt management allows developers to create, version, and share prompt templates. You can define variables in the template, like product descriptions, that are replaced with dynamic values at runtime. Check why each remaining option is not the best fit. B. Cross-region inference routes traffic for resilience, not for saving prompts. C. Knowledge bases securely connect models to internal data sources for RAG. Model evaluation assesses model outputs against metrics, not template management. Remember this decision rule. Bedrock Prompt Management is the native tool for saving, versioning, and reusing parameterized instructions. Let's analyze question number 397. Start by separating the facts from the requirement. A technology firm is updating its corporate responsible AI policies to require greater model transparency. As part of this initiative, the firm starts utilizing tools that explain how feature inputs influence model predictions. What is a direct benefit of improving model transparency in an organization? Check each option against the exact requirement. Option A is it eliminates the need for human-in-the-loop review processes. Option B is it automatically mitigates all historical bias in the training data. Option C is it exempts the organization from data residency compliance requirements. Option D is it improves the ability to audit decisions and strengthen AI governance. The correct choice is D. It improves the ability to audit decisions and strengthen AI governance. The decisive reason is transparency and explainability tools help stakeholders understand how an AI system makes decisions. This visibility makes it easier to spot biases, verify expected behavior, and meet governance and compliance requirements. The incorrect choices are plausible but unsuitable because A. Transparency enhances human oversight, it does not eliminate the need for it. B. Identifying how a model makes decisions does not automatically fix or mitigate bias. C. Transparency has no bearing on physical data residency compliance. Watch for this clue in similar questions. Transparency and explainability are foundational for responsible AI governance, auditing, and building user trust. Start by identifying the requirement in question number 398. Next, we enter the topic of model customization. Read the scenario with the target outcome in mind. A social media platform uses a large language model, LLM, to flag inappropriate posts. To better align the model with nuanced corporate ethics and rapidly shifting internet slang, the company plans to use human moderators to review model outputs, score them, and use these scores to improve the model directly. Which model optimization technique relies on human scoring of generated outputs to adapt model behavior? Review the options and eliminate any clear mismatch. Choice A. Retrieval Augmented Generation, RAG. Choice B. Reinforcement Learning from Human Feedback, RLHF. Choice C. Continued pre-training on general internet text. Choice D. Semantic search using vector databases. The option that satisfies the complete requirement is B. Reinforcement Learning from Human Feedback, RLHF. This option satisfies the complete requirement because RLHF is a customization technique that involves human reviewers rating or ranking model outputs. A reward model learns from these ratings and is used to fine-tune the LLM to align more closely with human preferences and values. Here is how to rule out the alternatives. A. RAG retrieves data at runtime, it does not change the model's fundamental behavior via scoring. C. Continued pre-training injects domain knowledge but lacks the nuanced behavioral alignment provided by human feedback loops. D. Semantic search is a retrieval mechanism, not an alignment or model training technique. Exam strategy. When a scenario requires adjusting model behavior and values based on human scoring or preference data, choose RLHF. Question number 399. Tests careful elimination. Pay attention to qualifiers such as least, most, and minimum. A developer testing a new generative AI application notices that when they submit the exact same prompt to an Amazon Bedrock language model 3 times, the model generates 3 slightly different responses. What is the primary reason for this behavior? Compare the options by fit, not by familiarity. Next, Option A. The application is failing to invoke the model's safety guardrails. Next, option B. Large language models inherently produce non-deterministic outputs. Next, option C. The model's context window is overflowing with historical data. Next, option D. The API connection is automatically rotating between different model versions. After elimination, select B. Large language models inherently produce non-deterministic outputs. The key clue points here because large language models generate tokens from probability distributions. Sampling and serving behavior can therefore produce different wording for the same prompt. Low randomness settings can improve consistency, but they do not guarantee identical outputs in every implementation. A. Guardrails evaluate safety and policy conditions. They are not the normal cause of output variation. C. Context window overflow can cause rejection or truncation, not ordinary wording differences. D. Standard output variation does not imply that the API silently switched model versions. Use this elimination rule in the exam. Generative models are probabilistic. Lower temperature can reduce variability, but consistency is not the same as guaranteed determinism. Work through question number 400. Step by step. We are moving to data labeling. First, locate the key operational constraint. A retail bank has millions of short, non-sensitive text descriptions of transactions. To train a supervised text classification model that assigns spending categories, the bank needs accurate labels for the dataset. Which two Amazon SageMaker ground truth approaches can help create these labels? Choose two. Choose every applicable answer and reject partial matches. Use the scenario constraints to assess these choices. Option A is use a vendor, private, or Amazon Mechanical Turk workforce to label the text records. Option B is run a SageMaker AI batch transform job on the unlabeled text. Option C is enable automated data labeling for a supported text classification labeling job. Option D is use Amazon TextTrack to infer spending categories from the text records. Option E is run unsupervised clustering and treat the clusters as guaranteed ground truth labels. The correct choice is A. Use a vendor, private, or Amazon Mechanical Turk workforce to label the text records. C. Enable automated data labeling for a supported text classification labeling job. Here is the reasoning that confirms the answer. Ground truth supports human workforces for labeling and can use active learning to automate labeling for supported built-in task types, including eligible text classification jobs. Mechanical Turk is appropriate only when the input is free of PII. The remaining options fail one or more requirements because B. Batch transform runs inference with an existing model, it does not create verified labels. D. TextTrack extracts text and document structure but does not assign the required spending categories. E. Clustering finds groups without predefined labels and does not guarantee supervised ground truth. Ground truth combines human labeling with optional automated labeling for supported task types. Public workforces require non-sensitive input. Question number 401. Find the decisive clue before choosing. Pay attention to qualifiers such as least, most, and minimum. A travel company built a generative AI chatbot using agents for Amazon Bedrock. The chatbot can converse naturally but cannot look up real-time flight availability or complete booking transactions in the company's external reservation system. How can the developers enable the agent to perform these actions? Compare the options by fit, not by familiarity. Consider option A. Increase the model's maximum token limit to generate longer responses. Consider option B. Implement action groups with custom APIs that interface with the reservation system. Consider option C. Use zero-shot prompting to instruct the model to guess the flight details. Consider option D. Switch the foundation model to one trained specifically on historical flight data. The required response is B. Implement action groups with custom APIs that interface with the reservation system. The requirement to solution matches agents for Amazon Bedrock use action groups to interact with external systems. By defining an OpenAPI schema and an AWS Lambda function, the custom API, the agent can execute tasks like booking flights or looking up live availability. Now eliminate the distractors. A. Token limits dictate output length, not system integration capability. C. Zero-shot prompting relies only on the model's pre-trained weights. It cannot access real-time external data. D. A specifically trained model cannot process live API transactions like booking a flight. A useful exam pattern is this. To allow Amazon Bedrock agents to take actions in external systems, configure action groups connected to APIs Lambda. For question number 402. Separate the requirement from the distractors. Next, we enter the topic of Bedrock pricing. Look for the wording that eliminates the distractors. An e-commerce company uses a foundation model that supports Amazon Bedrock batch inference to generate descriptions for thousands of new products. The job runs asynchronously once a week, and no real-time response is required. Which Amazon Bedrock capability is the most cost-effective for this workload? Watch for distractors that are valid services but wrong for this scenario. Consider option A. On-demand inference. Consider option B. Provision throughput. Consider option C. Amazon Bedrock batch inference. Consider option D. Amazon Bedrock model evaluation. The best answer is C. Amazon Bedrock batch inference. Batch inference processes high-volume requests asynchronously and, for supported models, is priced lower than on-demand inference. It fits periodic offline work that does not require interactive latency. Check why each remaining option is not the best fit. A. On-demand inference is useful for immediate requests but is less economical than supported batch pricing for this offline workload. B. Provision throughput reserves capacity for predictable throughput and is unnecessary for a weekly non-urgent job. D. Model evaluation measures model quality. It does not perform the production generation workload. Remember this decision rule. Use Bedrock batch inference for supported, high-volume, non-urgent workloads, verify model and region support before selection. Let's analyze question number 403. Read the scenario with the target outcome in mind. A graphic designer uses Amazon Nova Canvas to generate conceptual artwork. The designer wants to reduce the likelihood that generated images contain text overlays or watermarks. Which prompt engineering technique lets the designer specify elements the model should avoid? Review the options and eliminate any clear mismatch. Choice A. Few-shot prompting. Choice B. Negative prompting. Choice C. Chain of thought prompting. Choice D. In painting. The option that satisfies the complete requirement is B. Negative prompting. The decisive reason is a negative prompt identifies objects or style characteristics that the image model should avoid, such as text or watermarks. It guides generation away from unwanted elements but does not guarantee that every generated image will exclude them. The incorrect choices are plausible but unsuitable because A. Few-shot prompting supplies examples and is not the direct control for excluded visual elements. C. Chain of thought prompting concerns reasoning workflows, not image exclusions. D. In painting, edits a selected region of an existing image rather than defining global exclusions for a new image. Watch for this clue in similar questions. Use negative prompts to guide image generation away from unwanted content, then review the output because the control is probabilistic. Work through question number 404. Step by step. We are moving to Bedrock guardrails. Review the scenario and identify what must be achieved. A university deploys a student-facing AI tutor. Security testing shows that users sometimes submit role-playing or instruction override prompts intended to bypass the tutor's safety rules. Which Amazon Bedrock guardrails feature is designed to help detect and filter these malicious inputs? Check each option against the exact requirement. Option A is contextual grounding checks. Option B is prompt attack filters. Option C is sensitive information filters. Option D is word filters. After elimination, select B, prompt attack filters. This option satisfies the complete requirement because prompt attack filters are designed to help detect and filter user inputs that attempt prompt injection or jailbreak techniques. Guardrail configuration and testing are still required because no filter guarantees detection of every attack. Here is how to rule out the alternatives. A. Contextual grounding checks evaluate whether responses are grounded in supplied source material. C. Sensitive information filters block or mask PII and other configured sensitive data. D. Word filters match configured words or phrases and are not the dedicated prompt attack control. Exam strategy. Use Bedrock guardrails prompt attack filters as one layer of defense against prompt injection and jailbreak attempts. Question number 405 is a good test of exam judgment. This scenario tests whether you recognize the controlling constraint. An insurance provider wants a foundation model to answer policy coverage questions using the latest official policy documents in an internal data store. Policies change frequently, and the provider wants to improve grounding without retraining the model after every update. Which approach meets this requirement most effectively? The exam distinction is hidden in these choices. Now examine choice A, Retrieval Augmented Generation, RAG. Now examine choice B, Continued Pre-training on Public Insurance Data. Now examine choice C, Reinforcement Learning from Human Feedback, RLHF. Now examine choice D, increasing only the model's context window limit. The best answer is A, Retrieval Augmented Generation, RAG. The key clue points here because RAG retrieves relevant passages from current authoritative documents and supplies them to the model at inference time. This can improve grounding and freshness without updating model weights, although retrieval and generation quality still require evaluation. B. Continued pre-training changes model weights and is poorly suited to frequent document updates. C. RLHF aligns behavior with human preferences but does not provide current policy facts at inference. D. A larger context window does not identify and retrieve the relevant policy content by itself. Use this elimination rule in the exam. Use RAG for frequently changing private knowledge. It improves grounding but does not guarantee factual correctness. Approach question number 406. By checking every constraint. Identify the decisive constraint before considering the options. A credit card provider uses machine learning to score applications. Financial regulations require the provider to demonstrate exactly what data was used to train specific versions of the model and to prove that data privacy policies were followed. Which practice is essential for complying with these governance requirements? Eliminate every option that violates even one requirement. Next, option A, training the model exclusively on unlabeled synthetic data. Next, option B, implementing robust data lifecycle management and data lineage tracking. Next, option C, disabling all logging during inference to maximize data privacy. Next, option D, providing end users with direct access to modify the model weights. The correct choice is B, implementing robust data lifecycle management and data lineage tracking. Here is the reasoning that confirms the answer. Data governance in AI requires knowing where data originated, how it was processed, and how long it is retained. Tracking data lineage and managing its life cycle is essential to prove compliance with financial and privacy regulations. The remaining options fail one or more requirements because A, synthetic data is useful, but regulations typically govern how real customer data is handled. Training exclusively on synthetic data is rarely feasible for accurate risk scoring. C, disabling logging completely destroys auditability and hinders governance. D, end users should never have direct access to modify production model weights. Data lineage, tracking the origin and movement of data, and lifecycle management are core components of AI data governance. Next, question number 407. A startup has spent significant time crafting highly specialized system prompts that define the unique persona and logic of their AI application. They are concerned that malicious users might trick the application into revealing these underlying instructions. What is the term for this generative AI security vulnerability? Option A, data poisoning. Option B, prompt leakage. Option C, model inversion. Option D, output hallucination. The required response is B, prompt leakage. The requirement to solution match is prompt leakage occurs when a user successfully tricks a generative AI application into outputting its hidden, developer-defined system prompts or underlying instructions. Now eliminate the distractors. A, data poisoning involves maliciously altering the training dataset before the model is built. C, model inversion attempts to reconstruct sensitive training data from model outputs, not the system prompt. D, hallucination is when a model confidently makes up incorrect facts. It is an accuracy issue, not a targeted security attack. A useful exam pattern is this. The risk of an LLM revealing its internal system instructions to a user is known as prompt leakage. Question number 408. Review the scenario. A software company wants to create an AI coding assistant. Instead of relying purely on a generalized pre-trained model, they want to permanently adjust the model's internal parameters so it mimics the company's proprietary coding style and specific internal framework syntaxes. Which technique involves updating the model weights using the company's proprietary data? The choices are: Option A, implementing ARAG architecture with a vector database. Option B, utilizing zero-shot prompt engineering. Option C, fine-tuning a pre-trained foundation model. Option D, applying an Amazon Bedrock guardrail. After elimination, select C, fine-tuning a pre-trained foundation model. Fine-tuning involves taking an existing foundation model and continuing its training on a smaller, domain-specific dataset. This permanently adjusts the model's internal weights so it naturally adopts the style, syntax, and knowledge of the target domain. Check why each remaining option is not the best fit. A. RAG fetches context at runtime. It does not permanently change the model's internal parameters, weights. B. Zero-shot prompting relies entirely on the base model without providing examples or updating weights. D. Guardrails filter inputs and outputs. They do not alter the model's inherent coding style or parameters. Remember this decision rule. If a scenario requires changing the internal weights of a foundation model to adapt to a specific domain or style, select fine-tuning. Question number 409. Focus. A data engineer is cataloging datasets in an Amazon S3 data lake to determine which are suitable for immediate relational analysis and which require natural language processing. Which of the following datasets represents structured data? Compare. Option A. A tabular CSV file containing daily temperature readings and dates. Option B. A collection of audio recordings from customer support calls. Option C. A folder of scanned PDF receipts. Option D. A repository of raw customer product reviews. The option that satisfies the complete requirement is A. A tabular CSV file containing daily temperature readings and dates. The decisive reason is structured data is highly organized and formatted in a way that is easily searchable in relational databases. A CSV file with defined rows and columns containing dates and numbers is a classic example of structured data. The incorrect choices are plausible, but unsuitable because B. Audio recordings are unstructured data. C. Scanned PDF documents are unstructured data. D. Free-form text reviews are unstructured data. Watch for this clue in similar questions. Structured data fits neatly into rows and columns, for example, CSV, SQL tables. Unstructured data includes text, audio, images, and video. Focus on the key wording in question number 410. Focus on the requirement that drives the design choice. A legal tech company regularly uses complex instructions with Amazon Bedrock foundation models to summarize case files. The developers want a centralized way to version, test, and save these instructions within AWS so multiple applications can invoke them consistently. Which Amazon Bedrock feature satisfies this requirement? Focus on which option satisfies the complete requirement. Option A. Model customization. Option B. Knowledge bases. Option C. Prompt management. Option D. Provision throughput. After elimination, select C. Prompt management. This option satisfies the complete requirement because Amazon Bedrock Prompt Management enables developers to create, evaluate, version, and share prompts securely within AWS. This ensures consistency across different applications that need to invoke the same foundation model instructions. Here is how to rule out the alternatives. A. Model customization alters the model's weights, which is overkill for simply saving prompt instructions. B. Knowledge bases retrieve external data for RAG. They do not manage prompt templates. D. Provision throughput guarantees API capacity. It has no role in saving prompt logic. Exam strategy. To version and reuse complex instructions across AI applications, use Amazon Bedrock Prompt Management. Let's break down question number 411. This question moves us into AI use case selection. Start by separating the facts from the requirement. A hardware retailer has a catalog of 50,000 items that changes daily. The retailer wants a chatbot that grounds answers about item specifications in the latest catalog data. The team has limited ML experience and little time to launch. Which implementation strategy provides current, grounded answers with the least operational overhead? Now compare the choices one requirement at a time. Option A is fine-tune a foundation model on the entire catalog and retrain it every night. Option B is build a retrieval augmented generation (RAG) solution that retrieves specifications from the current product data store. Option C is train a custom foundation model from scratch using the product descriptions. Option D is deploy a distinct pre-trained model for each product category. The best answer is B. Build a retrieval augmented generation (RAG) solution that retrieves specifications from the current product data store. The key clue points here because RAG retrieves current product records at inference time and supplies the relevant context to the foundation model. It avoids frequent weight updates and requires less ML work than training or repeatedly fine-tuning models. Output quality still depends on the source data and retrieval design. A. Nightly fine-tuning is operationally heavy and is not an efficient mechanism for exact daily catalog updates. C. Training a foundation model from scratch requires substantial data, compute, and specialist expertise. D. Multiple category models add operational complexity and do not solve data freshness. Use this elimination rule in the exam. For frequently updated enterprise facts, RAG is usually more appropriate than embedding the facts through repeated model training. Question number 412 contains an important exam distinction. This scenario tests whether you recognize the controlling constraint. An IT department uses a foundation model to answer common support questions. The team wants less creative variation and more consistent wording when similar prompts are submitted. Which inference parameter adjustment generally increases response consistency? The exam distinction is hidden in these choices. Now examine choice A, increase the maximum output token limit. Now examine choice B, decrease the temperature parameter. Now examine choice C, increase the top p-value. Now examine choice D, decrease the model's training learning rate. The correct choice is B, decrease the temperature parameter. Here is the reasoning that confirms the answer. Temperature influences randomness in token sampling. Lowering it generally narrows variation and makes responses more consistent. It does not guarantee identical outputs or make unsupported information factual. The remaining options fail one or more requirements because the output token limit controls response length, not sampling randomness. C. Increasing TOPI broadens the candidate token probability mass and can increase variation. D. Learning rate is a training hyperparameter, not an inference control. Lower temperature generally reduces creativity and variability. Factuality must be addressed through grounding and evaluation. Move to question number 413. A financial services firm hosts a generative AI application on Amazon EC2 instances in an Amazon VPC. Security policy requires calls to the Amazon Bedrock Inference APIs to remain on the AWS network without using an Internet Gateway or NAT gateway. Which networking configuration meets this requirement? Choice A. Configure AWS WAF for the Amazon Bedrock API. Choice B. Create an Amazon Bedrock Runtime Interface VPC endpoint powered by AWS Private Link. Choice C. Route the requests through Amazon CloudFront. Choice D. Establish an AWS site-to-site VPN to the public Amazon Bedrock endpoint. The required response is B. Create an Amazon Bedrock Runtime Interface VPC endpoint powered by AWS Private Link. The requirement to solution match is an interface VPC endpoint for the Bedrock Runtime APIs uses AWS Private Link so resources in the VPC can call Amazon Bedrock privately without an Internet Gateway or NAT gateway. Now eliminate the distractors. A. AWS WAF filters supported web traffic but does not create private VPC to Bedrock connectivity. C. CloudFront is a content delivery service and does not provide the required private API path. D. Site-to-site VPN connects an on-premises network to a VPC. It is not the private service endpoint for Bedrock. A useful exam pattern is this. For private Bedrock inference from AVPC, use the appropriate Bedrock runtime interface endpoint powered by AWS Private Link. Question number 414. Tests careful elimination. The focus now shifts to human oversight. Pay attention to qualifiers such as least, most, and minimum. An insurance company uses a machine learning model to estimate vehicle damage costs from photos. If the model is less than 85% confident in its estimate, the company wants the photo routed to a human claims adjuster for manual review before the claim is processed. Which AWS service is designed to implement this human-in-the-loop workflow? Watch for distractors that are valid services but wrong for this scenario. Next, option A, Amazon Augmented AI, Amazon A2I. Next, option B, Amazon SageMaker Model Monitor. Next, option C, Amazon Bedrock Guardrails. Next, option D, Amazon Recognition Custom Labels. The option that satisfies the complete requirement is A, Amazon Augmented AI, Amazon A2I. Amazon A2I is a purpose-built AWS service that makes it easy to build workflows requiring human review of machine learning predictions. It can route low-confidence ML outputs directly to human workers for validation. Check why each remaining option is not the best fit. B. SageMaker Model Monitor watches for data and concept drift. It does not orchestrate human-in-the-loop task routing. C. Bedrock Guardrails filter generative AI inputs and outputs. They do not manage human review queues. D. Recognition Custom Labels is for training custom computer vision models, not orchestrating human reviews. Remember this decision rule. When a scenario requires routing low-confidence ML predictions to human reviewers, human-in-the-loop, choose Amazon A2I. Question number 415. Find the decisive clue before choosing. Identify the decisive constraint before considering the options. A software team has developed a generative AI writing assistant. They want to understand how the feature impacts actual user productivity and satisfaction in a live environment, rather than relying solely on automated benchmark datasets. Which evaluation method best measures the model's performance in real-world application usage? Compare the options by fit, not by familiarity. Consider option A, calculating the model's F1 score on a holdout dataset. Consider option B, performing A/B testing with a segment of live users. Consider option C, analyzing the semantic distance of the model's vector embeddings. Consider option D, conducting an automated adversarial prompt analysis. After elimination, select B, performing A/B testing with a segment of live users. The decisive reason is A/B testing involves deploying to different versions of a feature, for example, one with the AI, one without, or two different prompts, to live users. This provides concrete metrics on how the model impacts real-world behavior and business outcomes. The incorrect choices are plausible, but unsuitable because A. F1 score on a holdout set evaluates offline predictive accuracy, not real-world application performance. C. Semantic distance measures embedding relationships. It does not track user satisfaction or application success. D. Adversarial analysis tests security robustness in isolation, not real-world application performance. Watch for this clue in similar questions. To measure how generative AI affects actual users and business goals, perform A/B testing in the production application. Next is question number 416. The focus now shifts to Bedrock Guardrails. Identify the requirement in this scenario. A telecommunications company has deployed a generative AI assistant on its public website to help customers troubleshoot internet issues. The company needs to prevent the assistant from offering advice on competitor services or discussing unrelated topics like cooking or sports. Which solution enforces this restriction with the least amount of custom code? Review the options. Option A. Write an AWS Lambda function to parse all user inputs for competitor names. Option B. Fine-tune a custom language model using only telecommunications data. Option C. Configure an Amazon Bedrock guardrail with a denied topics policy. Option D. Set the model's temperature parameter to 0. The correct choice is C. Configure an Amazon Bedrock guardrail with a denied topics policy. This option satisfies the complete requirement because Amazon Bedrock guardrails allows you to define natural language descriptions of topics the model must avoid, denied topics. This is a native, managed feature that requires virtually no custom coding or operational overhead. Here is how to rule out the alternatives. A. Writing custom Lambda functions to parse text is high operational overhead and brittle. B. Fine-tuning requires deep ML expertise, significant time, and data prep, making it high effort. D. Setting temperature to 0 makes responses deterministic but does not prevent the model from answering questions about sports or cooking. Exam strategy. To prevent an AI assistant from discussing specific subjects with the least operational overhead, use Amazon Bedrock guardrails, denied topics. Next, question number 417. Scenario. A customer support center deploys an AI agent to pre-screen callers, collect account details, and resolve simple issues before transferring complex cases to human staff. The business goal is to reduce the number of cases that require human agent involvement. Which metric best evaluates success against this objective? Options. Option A. Model inference latency. Option B. Percentage of caller issues resolved without transfer to a human agent. Option C. Monthly website visitor engagement rate. Option D. Mean squared error, MSE, of the language model. The best answer is B. Percentage of caller issues resolved without transfer to a human agent. The key clue points here because the containment or deflection rate directly measures how often the AI completes a caller's issue without requiring human agent work. It aligns more closely with the stated workload reduction goal than a technical model metric or the duration of only transferred calls. A. Inference latency measures technical responsiveness, not avoided human workload. C. Website engagement is unrelated to contact center case handling. D. MSE is a regression metric and does not measure contact center business impact. Use this elimination rule in the exam. Choose a business metric that directly measures the desired outcome. Workload reduction is best tracked by containment, deflection, or avoided escalations. Next is question number 418. Scenario. A news organization uses an LLM to generate brief summaries of long-form articles. Data scientists want to programmatically evaluate the quality of the generated summaries by measuring how much they overlap with gold standard reference summaries written by human editors. Which evaluation metric is standard for this task? Review the options. Choice A. Rouge, recall-oriented understudy for gisting evaluation. Choice B. F1 score. Choice C. Perplexity. Choice D. Frechet inception distance, FID. The required response is A. Rouge, recall-oriented understudy for gisting evaluation. Here is the reasoning that confirms the answer. Rouge measures overlap between a generated summary and one or more reference summaries, commonly using matching engrams or sequences. It is widely used for reference-based evaluation of summarization quality. The remaining options fail one or more requirements because B. F1 is commonly used for classification and does not directly evaluate summary overlap in this question. C. Perplexity measures how well a language model predicts text, not agreement with a human reference summary. D. Frechet inception distance evaluates generated images, not text summaries. Rouge is commonly associated with summarization. Blue is commonly associated with machine translation. Question number 419. Tests careful elimination. We are moving to model customization. Look for the wording that eliminates the distractors. An enterprise has deployed a customized AI assistant to help employees draft emails. The application includes thumbs up and thumbs down buttons for each response. The data science team wants to use this accumulated user preference data to continually train and align the foundation model's underlying behavior. Which technique utilizes this type of preference data to update model weights? Eliminate every option that violates even one requirement. Consider option A, zero-shot prompt engineering. Consider option B, reinforcement learning from human feedback, RLHF. Consider option C, implementing Amazon Bedrock guardrails. Consider option D, enabling semantic chunking in knowledge bases. The option that satisfies the complete requirement is B, reinforcement learning from human feedback, RLHF. The requirement to solution matches RLHF uses human feedback, such as upvotes, downvotes, or rankings, to create a reward model. This reward model is then used to fine-tune the foundation model's weights via reinforcement learning, aligning its outputs with human preferences. Now eliminate the distractors. A. Zero-shot prompting does not use feedback to update model behavior, it just provides instructions. C. Guardrails apply filters on top of the model, they do not use feedback data to train or align the core model weights. D. Semantic chunking improves RAG retrieval, not model alignment based on human preference. A useful exam pattern is this. When human preference data, like ratings or rankings, is used to continuously refine a model's underlying behavior, the technique is RLHF. Question number 420. An organization is preparing a large corpus of text to fine-tune a language model for a public-facing application. The AI governance board mandates that the data preparation process adhere to responsible AI principles to minimize potential harm. Which actions align with these responsible AI guidelines? Choose two. More than one answer may be correct, so evaluate every option. Option A. Use datasets primarily sourced from a single demographic to ensure high consistency. Option B. Ensure the training data includes diverse sources representing different populations. Option C. Apply consistent and unbiased standards during the data labeling process. Option D. Exclude all automated human-in-the-loop review phases to accelerate training. Option E. Prioritize sheer data volume over data quality and accuracy. After elimination, select B. Ensure the training data includes diverse sources representing different populations. C. Apply consistent and unbiased standards during the data labeling process. Responsible AI practices require addressing bias at the data stage. This means curating demographically diverse datasets to prevent underrepresentation and ensuring human annotators apply consistent, fair standards when labeling data. Check why each remaining option is not the best fit. A. Sourcing from a single demographic introduces heavy bias and violates fairness principles. D. Excluding human review increases the risk of harmful or biased outputs slipping through. Human oversight is a key responsible AI tenet. E. Prioritizing sheer volume over quality often introduces toxic or biased data, directly violating responsible AI principles. Remember this decision rule. To mitigate bias during data preparation, use demographically diverse data sources and enforce strict, consistent labeling standards. You have completed part 15 of the AIF-C01 exam practice series. Continue your preparation by opening the complete playlist and watching the remaining parts in sequence. Please like this video, subscribe to Tech with Kaushik, and enable notifications for more certification exam preparation content. Share your score, questions, or feedback in the comments. Thank you for watching. See you in the next part.